Good morning, ladies and gentlemen. Today we are going to solve graphically a system of equations that includes a quadratic, so a parabola, and also a straight line. Now you may recall back in chapter 10 we graphed systems of equations that only included straight lines. So we're going to take our new type of graph, our parabola, and we are going to either intersect it with a line, or if you take a look at this table here, we have three real possibilities. So either that line goes through the parabola, which gives you two solutions, and those solutions would be here and here. So that would be the solution to the problem, those two coordinates. Or, because of a cleverly designed system, the parabola and the line just kind of nick each other. They just touch. And there's one solution. So here you see the line does not actually go through the parabola, but it just touches it. And it looks like the turning point there, but it doesn't have to be the turning point of the parabola. It can be at any point. This is actually called a tangent line, and that's kind of a geometry concept, but that would be a nice extra credit question, a tangent line. And then we have a third possibility here where there are no solutions. Because the line is drawn in such a way that it completely misses the parabola. We have three steps followed by a check that you can do here to solve these. Step one, we are going to graph the quadratic equation. That's going to get you, say this is a 10-point question, 4 points will be graphing the quadratic equation, maybe 5 points. You're going to graph the straight line, so this will be review from chapter 10, and then we're going to look at the picture and we're going to identify where those curves, where the curve and the line intersects. And then you have to check. You have to check. That's very important. Alright, so let's take a look at a couple of examples here. Now if you're really good at graphing parabolas, this is going to seem pretty simple. If not, let's try to pick it up again. Remember that the standard form of a quadratic is y equals ax squared plus bx plus c. So if I put my quadratic right underneath it, it allows me to identify that a is 1, I can put that 1 in there, that b is -6, and that c is +6. I need that because the formula for axis of symmetry is x equals -b over 2a. So this is the axis of symmetry formula, x equals b over 2a, which we've seen a bunch of times. So in this case it becomes -6 over 2 times 1, which is equal to 6 over 2, or x equals 3 as your axis of symmetry. I need that because I'm going to put that in the middle of my table. So 3 goes in the middle of my table. I go 3 points above it, 2, 1, 0. 3 points below it, 4, 5, and 6. I have to graph 7 coordinates when I graph a parabola. So those are my 7 coordinates. I go to the calculator here and I type in x squared minus 6x plus 6. And I go to my table of values. And once again, if you look at your chart, I have 3 that's supposed to be in the middle of my chart. So I'm going to arrow down a little bit. You can see nice symmetry in the y column if I move to right there. Okay, I can move this over just for easy use, and we can copy these values over. So 0, 6, 1, 1, 2, -2, 3, -3, 4, -2, 5, 1, and 6, 6. So we're going to plot these values. So 1, 2, 3, 4, 5, 0, 6 is here, 1, 1, 2, -2, 3, -3, 4, -2, 5, 1, and 6, 6. Okay, we graph this. And I'll hold off labeling for a moment until I draw the line so it doesn't get too sloppy. But that does have to be labeled for full credit. Alright, I'll switch colors here for y equals x minus 4. Y equals x minus 4, just to remind you how to graph a line. We only use 3 values for that. Typically 2, 0, and -2 are the 3 values that we use for x. You are ready to put this in the calculator when the equation is solved for y. You do see y equals x minus 4 is already solved for y. So I'm going to put that in as y2. So I have x minus 4, hit second in table, and I want to know what I get when x is 2. You can see it here. When x is 2, y is negative 2. And when x is 0, y is negative 4. You can see that right here. Now y2 is this equation. And when x is negative 2, I'll have to arrow up to get to that. Whoops, I'm in the wrong column. There we go. When x is negative 2, y sub 2 is negative 6. So I plot these points on here. 2, negative 2 puts me right here. 0, negative 4 puts me here. And negative 2, negative 6 puts me there. So if you notice, when I draw this line, it's going to come through and right down here like so. So I have a point of intersection there. I have to label all these points. So going back, 0, 6, 1, 1, 2, negative 2, which is a solution, so I'm going to box it up. 3, negative 3, 4, negative 2, 5, 1, and 6, 6. I'll put the equation of the graph on there. And switch over to the line. Now I have negative 2, negative 6. I have 0, negative 4. And I already have 2, negative 2 labeled. So I go y equals x minus 4. So do all that labeling stuff for the parabola and the line. Okay. So I have my two solutions. One of them was 2, 2. 5, negative 1 was the other one. So I'm going to write that off on the side. Solutions. 2, negative 2, and 5, 1 are the solutions to this. And it's done. It's incredibly messy, I know, but you know, with your separate sheet of paper, it's easy enough to keep it a little bit more organized. Alright, let's take a look at example number 2 here. So once again, in the first equation, a is equal to 1, b is equal to 2, and c is equal to negative 3. So I can do x equals negative b over 2a, which is negative 2 over 2 times 1, and that's going to simplify to be x equals negative 1. So that's your axis of symmetry. So that's going to go in the middle of my table. I'll count 3 integers before it, and 3 integers after it, and x and y. Y equals negative 3 is a special case. I don't have to make a table of values for that, and we'll talk about that in a minute. So go into the calculator. Going to the calculator, hit y equals, I'll clear that. I have x squared plus 2x minus 3 to put in here. So x squared minus 2x plus 3. I'll clear this other equation out. And I hit the second and the table key. Now axis of symmetry is x equals negative 1. So I want to have negative 1 in the middle of my table. And there you see it right there. And notice the table of values, it looks a little bit problematic. I don't have symmetry on both sides of that, so this is an indication that there's an error. So going back, negative b, so negative 2 over 2 times a, or 2 times 1 would be negative 2 over 2. So x equals negative 1 should be the correct axis of symmetry. So now I got to check my equation. X squared, look at that, plus sign, and that's supposed to be a minus sign. I typed my equation in incorrectly. So that's a little bit of the kind of looking at your table, you can sort of figure out, hey, I made a mistake, and then hopefully fix it. So you have like a little built-in error checking mechanism there, because there should be symmetry in your table. Alright, so negative 1 gives me negative 4, negative 2 and 0 both give me negative 3. Negative 3 is 0. There's a root. 1 is 0. There's another root. We don't care about roots for this. We want to know where the line and the curve cross each other. So don't accidentally identify roots as like the solution to the problem. Otherwise you're going to have a mistake. 1, 2, 3, 4, 5. Negative 4, 5. Negative 3, 0. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3. 1, 0. And 2, 5. And I try to draw a nice curve here. Always tough to make them look pretty, but they are beautiful. They represent real world stuff. Quadratic equations do. Okay? So I can label these points. It's easy enough to do now. Negative 4, 5. We have negative 3, 0. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3. 1, 0. And 2, 5. And I can put the equation on here as well. Y equals x squared plus 2x minus 3. So that's completely done. I can even get the arrows on the axis right now. Alright, y equals negative 3. I'm going to switch to blue for this. Y equals negative 3 is a special case. It's a horizontal line. It's the line that crosses the y-axis at negative 3. So I'm going to come down here, go to negative 3, and just draw this line straight across. You do not have to label coordinates on that line. You just have to put the equation. So y equals negative 3 is on there, and I'm good. Look at the points of intersection. I got 0, negative 3 here, and I have negative 2, negative 3. Okay, so I'm going to write down that those are the solutions. And we are going to write them down, negative 2, negative 3, and 0, negative 3. Alright, let's talk about checks. Let's talk about how to do the checks for these problems. We have 4 checks to do for full credit. I know it seems like a lot, but you're getting credit for each one that you do. So, let's do the checks. I'm going to take that first equation, y equals x squared plus 2x minus 3. I'll take one of my points, which is negative 2, negative 3. Y is negative 3, x is negative 2. I'm just going to do order of operations on the right. So exponents first, then we can do multiplication. 4 minus 4 is 0, so I get negative 3 equals negative 3, and it checks. For the other point, I have negative 3, 0. So negative 3 is equal to 0 squared plus 2 times 0 minus 3. Negative 3 is equal to 0 plus 0 minus 3. Negative 3 equals negative 3. So there's a second check. Now I have to graph the equation y equals negative 3. So y equals negative 3. It's very easy to check. Negative 2, negative 3 is one of my solutions, so take negative 3 for y. Look how fast that checks. And then I got y equals negative 3 again, and for the other point, negative 3 equals negative 3, and that checks as well. So there's your 4 checks, and they're worth points. Without the checks, the highest score you can get is an 80. And what a shame. You did all the graphing, you found where they intersected at these 2 points. You found their coordinates, but then you only got an 80 because you didn't do the checks. It's pretty common. Alright, one more problem here. Y equals x squared plus x minus 4. Our buddy, the fractional axis of symmetry, is going to come in here, and it's not going to matter. We're going to ace it. So we have a equals 1, b equals 1, c equals negative 4. So x is equal to negative b over 2a is negative 1 over 2 times 1, which is negative 1/2, or x equals negative 0.5. Okay, so negative 0.5 goes in the middle of our table. Integers smaller than 0.5 are negative 1, negative 2, and negative 3. Larger than negative 0.5 are 0, 1, and 2. So when we go to our table of values here, well, let's get our equation typed in. So we'll clear that out. I got x squared plus x minus 4. X squared plus x minus 4. I hit second and table here. So 0.5 goes in the middle. I won't be using this entire table, but I'll be using a lot of it. So negative 3, 2, negative 2, negative 2, negative 1, negative 4, 0, negative 4, 1, negative 2, and 2, 2. We go to our graph, hit second calc, which is above the trace key, and I want to know what value I get when I put in negative 0.5. So I type negative 0.5 and hit enter. Negative 4.25 is the result. And we're all set and ready to graph. Negative 4.25. A little sloppy there. Okay. So coming over here, negative 3, 2, negative 2, negative 2, negative 1, negative 4, negative 0.5. Okay, so we're plotting points here. Let's see, we have negative 0.5, negative 4.25. So that's going to be like right here. 0, negative 4, 1, negative 2, and 2, 2. Don't mess with my 2, 2. There used to be a song on the Golden Oldies channel. Don't mess with my 2, 2. It always comes to mind whenever I plot the point 2, 2. Okay, so we'll get these labeled up. So we got negative 2, negative 2, 1, negative 4. Of course, this gets real messy down here, but just do your best. Try to make the labels as close to the points as humanly possible without turning it into the messiest thing you've ever drawn, you know. And we'll label y equals x squared plus x minus 4. So there's our graph. We have the first one done. Now what makes the second graph really interesting is that it's not solved for y. So let's solve the equation for y. We want to undo addition and subtraction first, so let's get the 2x out of there. Now please note that negative 2x and 2 are not like terms. And then we're going to divide everything by negative 1. Or multiply everything by negative 1, but we have to switch the signs of all the terms. And you get y equals 2x minus 2. So we make our x and y column, 2, 0, negative 2. We type this into our calculator. 2x minus 2 is the equation. Alright, we got 2x minus 2. Go to your table of values. And it does appear I have all of them on there. So I'm going to drag this over here. There you go. When x is negative 2, y is negative 6. When x is 0, we have a negative 2. And when positive 2, y is positive 2. So we plot these points. As you can see, 2, 2 is actually a solution. 0, negative 2 here. And negative 2, negative 4, 5, 6, 2, 3, 4, 5, negative 2, negative 6 is right there. So when we draw this line, here, and there, and there, try to draw it as nice as we can. We do have to label a couple of these points. We got 0, negative 2, and we have negative 2, negative 6. So on a piece of graph paper where the squares are a little bigger, it looks a little bit nicer. It does appear that we have a solution here at 2, 2 and 1, negative 4. Although, because I didn't use a ruler, a little suspicious about that. So let's write these solutions down and then hopefully the checks will agree. So we got 2, 2 and we have 1, negative 4. Alright, so we're going to do our checks now. And I have lots of room so I can really explore the space and write a nice check. So I got y equals x squared plus x minus 4. And I'm going to check 2, 2. So x and y are both 2. Do order of operations, so exponents first. Of course, the 4 and the negative 4 are going to add up to be 0. So we're just going to have that, and it checks. Alright, the next check with this same equation is going to be on 1, 4. I like to write the equation down every time. So 4 for y, 1 for x. Okay, I go 4, oh, that's supposed to be negative 4. Whoops, 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 whoops. 1 plus 1 minus 4. And we see we get negative 4 is equal to negative 2. So we have a problem. Take a look at the graph and identify the problem. I see it. Can you see it? What did I do wrong? It was supposed to be negative right there, wasn't there? So that's supposed to be negative. So I have to go back and fix this. So we have negative 1 squared minus 1 minus 4. Negative 1 squared is positive 1. Minus 1 minus 4. 1 and negative 1 are additive inverses, so they disappear. And look at that. The check has allowed me to fix my mistake, and that's very important. Alright, the equation of our line, 2x minus y equals 2. So I'm going to try 2, 2 in there. So 2 times 2 minus 2 is equal to 2. 4 minus 2 is equal to 2. It's going to check out. Taking the same equation, 2x minus y equals 2. 2 times negative 1 minus a negative 4 is equal to 2. So that's negative 2 minus a negative 4 is equal to 2. That's negative 2 plus 4 is equal to 2. 2 equals 2. So it checks out. Alright, so you have some problems on page 528, 568, 11 through 14. My recommendation is you give a couple of them a try if you have time this evening, so that when you come in tomorrow you're feeling a little bit more confident about what you're doing. Have a great evening. I look forward to seeing you tomorrow. Don't forget, review book money is due by Friday.